From the last night, I see the colleagues here are in pretty good condition, except my colleague next to me. So I hope we will finish this session as it is written here. This is the session for broadband, and the presenters will show the technologies, case study here, measurements, maybe challenges, infrastructure sharing, and as yesterday we have presenters also from the region, from the vendors and from the regulators. The first will start Boris Arsov with his presentations, the benefits and regulation approaching for broadband internet access. First presentation, please.
Good morning to everyone. Sorry for my situation, I have a problem with my back. So my presentation is about the benefit and regulation approach to the broadband internet access. Actually, I will talk about our system that we implemented in 2020. So it is the integration of WebGIS portal, single point of information, and the WebGIS collector and NOBP implementation support system. Also, he has an opportunity to input planned projects that will be implemented in the future from agency. So the WebGIS portal is the center point for all special data under the jurisdiction of AEC. It is supported by a powerful, useful management system and the content management system for editing new application. So about the single point of information, the system enables minimum information regarding the planned construction of a public electronic communication network and means the existing physical infrastructure of entity that manages infrastructure facilities. It also enables support in giving consent for the basic project for construction of public electronic communication network, enables support for giving opportunities during preparation of documents for spatial planning, integrated with electronic system for issuing construction permits in association of the units of local self-government, and contribute the better utilization of already built and greater rationalization in the construction of the new networks. So about the GIS collector, there are three user roles. The first role is about the geodetic company that can provide data. The second one is operator of the electronic communication networks and associated facilities. And the third one is the employee of AEC that make the final validation and approval of submitted data. Also, the GIS collector can provide full electronic data delivery for newly built electronic communication networks and associated facilities. Also, automatically verify the correctness and completeness of the submitted data in accordance with the rules of submitting data for electronic communication networks and associated facilities. So this is the cover page for the National Operation Broadband Plan Implementation Support System with the menu for the left side and the tools that are in upper of the page. So this system can provide data regarding the areas of existing and planned coverage with fixed and mobile NGA networks in terms of technology and speed, upload and download. Can also map the use of the internet access service by settlements, especially in relation to secure speed, upload and download, and technology used. To update white, gray, and black zones in country and make them public. I should regularly update the previous data and publish them publicly in tabular and graphic format. And also can update the data posted on the SPI that refer to the free capacities in cable ducts and fiber optic cables. They are managed by the operators. So also can provide data regarding the areas of existing and planned coverage with fixed and mobile NGA networks in terms of technology and speed, upload and download. And this is a screenshot of one segment or part of the city of Ohrid, where we can see the some kind of data of the operators that have in that area by technology and about the upload and download speed. Also, the data for existing and planned fixed and mobile NGA coverage can be provided also with import of files in provided structure after successful validation of the file format and contained data. After finishing the process of data collection, recalculation of the white, gray, and black zones is done, literally, and with the click of a button, zones are calculated separately for speed between 30 megabits per second to 100 megabits per second, or also and for speed over the 100 megabits per second. Also, this system can map the use of the internet access service by settlements, especially in relation to secured speed, upload and download, and technology used. The data for internet access, the contracts by settlement can be entered manually to provide for the small operators, or the import of files in preferred structure for the bigger operators. Preparation of import of data for internet access on expect location contracts by the customer address. Now also this system have analytical tools that can be used from another institutions. For example, the network planners, Macedonian broadcast employers, and the broadband compliant office members, and they can use the data for their analysis also. This system can show the NGA zones, the internet service, by contracts, by settlement, and demographic data. Analytical tools consist of one screen filtering of data for internet service contracts by settlement, predefined reports for demographic data. They can be shown in PDF, Word, and Excel. It depends of the institution how does these reports want to be shown. And also the graphical dashboards for the white, gray, and black zones, NGN zones. Here in this slide, we can see that the system has tools for separately to show the results in the regions, also in the municipalities. So the planned project for 2022 building infrastructure terrestrial, optical fiber, and microwave transmission maps for Macedonia, gives application for view and analysis of results from measurement of parameters and quality of internet access in fixed network, analytical toolbox application for deep analysis of electronic communication networks and services, and quality of service parameters in mobile network and mobile coverage per technology. Thank you very much.
Do you have any question regarding this presentation? As I see, nobody asked for a question. Thank you, Mr. Arsov, for your presentation.
Thank you very much.
The next presentation will be from Macedonian Broadcasting Company. They will show something more about national backbone optical infrastructure, and according to the law, they are the company who are obliged to implement this national operational broadband plan. The presenter will be Mr. Aryan Ibrahimi.
Hello everybody, I hope you guys can hear me. I'm Aryan Ibrahimi and I come from National Broadcasting North Macedonia, the public enterprise. And today I will speak about, as Igor also as beautifully said, the construction and development of the National Backhaul Optical Infrastructure or Network, also called the NBON. Before actually going into details about this, I will present to you the agenda for today. First of all, we will go through the broadband. What is the broadband, and how come can we as end users connect to such kind of service or infrastructure? I will talk about the construction and the development of such kind of thing, the infrastructure of how we can define such kind of thing, a feasibility study, and at the end, the internet access that we as the end users can get access to and can use on a daily basis. So I see a lot of people today and also yesterday have been spoken about internet, broadband, such kind of terms that, I mean, if we take a second, how can we define such kind of thing? What is broadband, and what is it on a daily basis? Because that's basically what, at the end we need to think about. So broadband, in other words, basically means fast. It also means faster than what I had yesterday. We as humans always tend to try to get better things, or to reach new heights, new speeds, new everything basically. We also see that in various kind of markets where, different kind of trends and different kind of different kind of things happens, and it happens very, very, very fast. And if we think about that in a broadband perspective, as far as yesterday, when I reached to the hotel, the first thing I thought about was to get the Wi-Fi password for the hotel. I believe that many of you had the first thought as well. So basically, broadband and also internet access, the day-to-day has become a necessity. That has become something that we as human needs. If we think about that in a historical perspective, if we think 10 years ago, 10 years back, 15 years back, it wasn't the same need. Today, we need internet as we need energy, electricity, we need heat, and so on and so forth. So basically, it has become something that we really need. So when we have defined, or what I think we have done, is that we have defined what the term broadband really means, and how can we put that into perspective if we think about that in the North Macedonia, or the Republic of North Macedonia, and how can we implement such kind of thing. That can be done with these kind of steps. Back in 2019, a strategy for the implementation of the national operational broadband has been conducted and was created, and in that strategy, this as a figure was written, or was constructed, where the internet would be in the future connected to a backbone network, that backbone network to be connected to local networks, and then go to the first mile, or also called the end user connections. But before actually coming to that point where we can start constructing such kind of thing, we need to make some pre-analysis before actually, as I said, constructing that infrastructure. We, as a national broadcasting North Macedonia, has conducted some analysis, and as you can see here in this map, we have made contact to the public enterprises in North Macedonia that already had existing fiber optic infrastructure built with public funds. And we finally came to that point where we have data implemented into our geographical information system, also called the GIS platform, which you can see in this map. Furthermore, we also contacted all the municipalities, where we, in that request to those municipalities, had three requests. We had the request of them giving us some recommendation for Wi-Fi locations of the public institutions, and also the geographic location for municipalities and also municipal institutions. And we also got to that point where we finally can say that we have conducted that analysis, and we have a final result of 1,242 Wi-Fi locations implemented into our GIS platform. We have a total of 1,358 public institutions. I see that everybody has a problem with this. And then at the end, we have a total of 1,163 municipalities and also municipal institutions. With this taken into regard from the government of the Republic of North Macedonia, we were delegated another task where we had to, from those final analyses that I presented earlier, we had to, according to the work plan 2020-2024, we had to get all the locations for tourist attractions or tourist destinations. So we went further with that analysis, and we got to the point where 373 locations were extracted from that report and sent to the government. And on the 8th of March 2022, that report was implemented or was adopted and accepted as a list of free Wi-Fi points in the Republic of North Macedonia. So with all these pre-feasibility steps, if I can say so, we come to the point where we actually need to think about the feasibility study. As I said, first of all, we thought about the properties, where all the technical recommendation and properties of the national backhaul optical network has been thought about and has been conducted. The utilization of the existing infrastructure in North Macedonia, as you saw on the map earlier, all the infrastructure, all the existing optical physical network, and at the end the connection with all the network nodes, such as the entities, the backhauls, and so on and so forth. So these are basically the three main pillars that needs to be implemented in this feasibility study for us to begin with the actual construction of the network or the infrastructure. With that taken into regard, I know that it's a lot of information, and it takes, such kind of activities also takes time. But as I started with, it basically what the idea of such kind of thing is for us to have that internet access, is for us to be able to connect to different kind of service, to always have streaming services that we can access to, that we have a stable internet that we can connect different kind of services, for also the market to expand to reach newer heights. Nowadays we talk about megabit speed or megabyte speed, but actually what is able with the optical infrastructure is gigabit speeds, which is something that we nowadays hear about but never seen in real life. And that is something that we believe with the development of such kind of infrastructure we can reach, because that is technically possible with such kind of infrastructure. So with that taken into regard, we see that we, with the whole strategy, want to reach symmetrical internet access with high speeds. This was all I had for you until now. If any questions arise, I believe this is your part.
Okay, you already asked. If any questions, please ask. No questions at all. Thank you, Mr. Ibrahimi.
Thank you.
We are moving through the region. We are going to Montenegro with Ms. Mirjana Smolovic for her presentation overview of broadband access in Montenegro.
Good morning, everyone. Glad to see you in this number this morning after hard session last night. Do not resent me, this is my first public presentation, so if I'm a little bit confused, I'll start laughing probably. Or guys from Ekip, just put some music, everything's gonna be fine. I'm here today to present you an overview of broadband access in Montenegro. This presentation is full of numbers, and I'm trying to not to bother you too much with that, and to tell you some facts anyway. Tell you something about operators in the Montenegro, fixed broadband access, mobile broadband access, and something about two last strategies of development of ICT sector. We have 35 registered operators in Montenegro, from which 24 provides, from which 24 operators provide service of broadband access. 4 of them are fixed telephony operators, 3 of them are mobile telephony operators, 12 internet service providers, and 5 audiovisual media operators. Sector revenue and investments in Montenegro. In last period of 5 years, from 2016 to 2020, annual revenue in a sector was about over 200 million euros per year. From this revenue, in whole 5-year period, 39% were invested were investments in infrastructure, so significant development of networks and increase of broadband connections is present. This slide shows fixed broadband access subscribers, and as you can see, over the 10 years period, that number was over 100,000 increased. At the end of 2021, we have around 190 subscribers. To have clearer picture, number of households in Montenegro is 195,000. Regarding the penetration of his broadband access by households, as you can see on this graph, it's comparative overview in Montenegro and in European Union. Percentage in 2001 of household penetration with fixed broadband access was about 96%. This graph shows something about geographical distribution of penetration. This is by region. We have 24 municipalities in Montenegro, and we can divide Montenegro in 3 regions, northern, central, and southern region. 2 municipalities in northern region have only 2 operators who provide access. In the population in that municipalities is around 2.4% of population, and other 22 municipalities have 3 or more operators who provide fixed broadband access, and that's 97.6% of population in these municipalities. Reasons for this high is, as you can see, in 2021 we have in southern region penetration over 100%. Reason for that is because we are using numbers from last census in 2011 about households, and in the meantime too many new buildings and new buildings were constructed, so the number of users is much larger than the number of households. Those households are not yet in those numbers that we are counting for penetration. This slide is to point out significant change in use of technology. As you can see, from 2016 to 2021, the structure of technology is drastically changed. We had around 51% of usage of XDSL in 2016, and that percent is now around 29%. And fixed FTTX access increased from 11.30% to almost 43%. Although structure of subscribers by speed was changed during the years, we have a significant increase of usage of higher speeds, over 30 megabits per second. So one of data that I want to point out is that speeds access over 100 megabits per second reached 41%, while in 2016, as you can see on this graph, we didn't have subscribers using that speed. Now, a graph about internet traffic. We were changing yesterday these presentations. I tried to hijack Anna's presentation in time. I didn't do it successfully, and this is my old presentation, actually. So never mind, it's okay. We had a presentation that had two graphs showing whole internet traffic and average monthly internet traffic per user, but it's okay. This was the first version of presentation. You can see on this graph that internet traffic significantly usage was during the years increased. This slide shows mapping results of fixed broadband access. And on the left side, you can see coverage by access speed. And on the right side, you can see coverage by settlements. This graph shows that on the right side, you can see in this legend numbers of settlements in Montenegro. During 2020, agency applied a new methodology of calculating the availability of NGA broadband access. By implementing this broadband access mapping system, agency can calculate the values of this indicator with fairly high accuracy based on georeference data. Georeference data of electronic communication networks are provided by operators, and the Cadastre and State Property Administration submitted to the agency available data on geographical distribution of buildings with certain estimates of distribution of households. Households coverage by speed and technology, we can see on these graphs that households coverage shows that XDSL and FTTX are the most frequent technologies, while 15% of households are not covered by fixed broadband access. The most frequent speed of fixed broadband access is over 100 megabits per second. In this part of presentation, I'll give you a brief overview of mobile broadband. You can see on this graph the mobile internet users is slightly lower, number of them is slightly lower than number of inhabitants. In maybe someone will find it very strange, maybe in hearing presentations yesterday, it's not very strange. This increasing number is really actually a trend now. We have three mobile operators in Montenegro, and the number of users per operator is fairly uniform. Chart on this slide, it was charts, now it's one, shows the increase of mobile internet traffic, and this is the average monthly internet traffic per user in gigabytes. On this slide, we have shown coverage of territory and population with different mobile network technologies. And as you can see, the coverage is, the numbers of coverage or percents are very high. Well, my presentation so far, let's summarize it a little. We can conclude that during 2021, the increased trend of number of Montenegrin citizens accessing internet continued and led to increase in penetrations of fixed and mobile broadband access. We had two strategies. I pointed out two strategies of information society development in Montenegro. On this slide, you can see the table from Strategy for Information Society Development of Montenegro by 2020. Represents the strategy of continuity in relation with previous one. A life cycle of previous strategy ended in 2016. Parameters or indicators on this slide in their values are given. They are values in 2017, as well as target values planned by the strategy, and some values that we reach in 2021. Digital transformation strategy of Montenegro 2022-2026 is a new strategy that was adopted in 2021. We adopted also the plan of action plan for the period of 2020 and 2023. Challenges in digital transformation of Montenegro are addressed through two strategic goals. First strategic goal focuses on improving the capacities and capabilities for digital transformation, and the second goal focuses on strengthening the digital awareness on Montenegrin society and digital competitiveness of ICT sector. Well, I was fast, I think. I didn't bore you too much with those numbers. I was a bit confused, don't resent me, please. And maybe I'm going to be foolish, a bit foolish, but it's in my nature, so I'm going to tell you a joke. We were talking about this presentation when I made it, and I asked the director if is it possible to make a joke about us as a Montenegrins and using mobiles and stuff like that, and then he told me one really good joke, so I'm going to tell you that joke to you. In the States, United States, archaeologists start digging, and on that location they find under 200 meters under the surface, they found copper wire. So they concluded we were using fixed telephony 200 years ago. In Germany, they were digging and they find a piece of glass under the surface of under 500 meters, and they said, okay, we used optics 500 years ago. Then we in Montenegro start digging. That's a joke for itself, but we start digging, and we dig, and we didn't find anything. We reached 100 meters under the surface, and we concluded 100 years ago we were using mobile phones. Thank you for your attention. Any questions? I was clear. I'm sure you don't have questions.
Maybe Maybe another joke or
Some music? Some music maybe?
Montenegro.
Is it positive?
Yeah. Will be another music, still more.
Yes, I know.
Thank you, Mirjana, for your presentation. Very nice. Right now we are expecting something more advanced from Huawei, Mr. Hieronym Piotrowski.
Hello, hello. Yes. Congratulations, Mariana, for amazing first performance. Well, my name's Hieronym. Thank you very much for having me here. I work at Huawei in career business development. And after this nice joke, we'll move a little bit to something very serious, very important. And I'm super excited to have this amazing opportunity to share with you our story on how we at Huawei believe our industry, ICT industry, can transform itself, but also affect and transform the world that surrounds us to become more green and more sustainable. And this is one of our priorities. This is one of the key areas that we focus working together with our customers. So I brought here today a couple of stories, couple of use cases from our recent activities with our customers. So let's have a look at this. But before this, let's have a look at the topic of the green ICT and the green world in general. And as well, I brought some numbers that, for me at least, were super eye-opening. So I hope you'll like them as well. All right, I need to change the slides. Works? Works. So first things first, the carbon neutrality. This is the topic that, well, the term we all heard so many times, and this is the topic that we already can see becoming, we call it a global mission. So let's think and let's see where actually we are in all these buzzwords, how far we reached and how far we still are to reach so-called carbon neutrality. We can see that all the major economies, European Union, United States, Japan, plan to become carbon neutral by 2050. China will follow shortly after in 2060. This brings a huge pressure on enterprises, or on industries itself, to bear in mind, to consider and rethink their business models and readjust them to meet these very high requirements. And we can see that the ICT industry does follow, and we can see the major players on the market setting even more ambitious targets. So for example, Orange plans to be carbon neutral by 2040. Deutsche Telekom, on the other side, by 2040 plans to use all the energy from the natural resources. Those are very ambitious plans when we think of it, because we challenge them, all of us. Every year we consume more data, around 30%. That's both the consumers and the enterprises, businesses. Every year we consume more data. More data means more energy used to operate telecom networks. So for example, we can see Telenor forecasting that by 2050 they will use 30% more energy than they do currently. So that actually brings a very interesting question, which maybe you wondered before, how much we, as the ICT industry, contribute to the carbon emissions. How big contributor we are, how much carbon emissions we produce to serve our customers. Any idea by the percentage? Maybe someone has some rough idea? I would be afraid to guess as well, but I was very interested to see this. By 2030, we are going to produce around 2% of the whole global carbon emission. That's a huge number. We are a big contributor to the carbon emission. 2018 it was 1.5%, and it's rapidly growing. As we use more data, the industry needs to produce more carbon emissions itself. However, this is the carbon footprint. There's one more data that we should bear in mind. This is the carbon handprint. This is the total opposite to the carbon footprint. So basically, carbon handprint is all the activities that we do to avoid or to reduce the carbon emission. And if it comes to ICT industry, you might guess, you might try, carbon handprint is a lot higher than the carbon footprint. And let's see if it works. So basically, our industry has an amazing opportunity, amazing potential to reduce the global carbon emissions by 20%. And this is a huge responsibility that we hold. This is actually what we call the enablement effect of the industry, which is in this case 10 times higher than the emissions we produce. You might wonder where it comes from and how we bear this huge opportunity, this huge responsibility. Well, first from, of course, making our operations more green, but also by enabling with our technologies set of different industries to become more green. And well, there's hundreds of examples, but here I brought a couple of them which on the first sight don't seem to be so related to the ICT industry. My favorite probably the farming industry, where 5G technology enables us for real-time analysis of the field so that farmers can more precisely treat their farms. And avoid a huge number of the chemicals used during their operations. So those are the things that you don't think normally, but with our technology we have opportunity to change so many other industries, and this is why it's so important that we start from ourselves, bringing and transforming our operations. So the other question would be, what should we focus on? Where should we start this transformation, and what's the main key point to make ourselves a better and more green industry? In 2020, we did the Huawei Sustainability Report, which found out that if it comes for the network equipment, actually the huge majority, 80 or even 95% of the total emission during the entire life cycle of the products come from the usage moment. This is interesting because very often we hear about the production, the sustainable manufacturing and the production operations, which actually in the equipment case produce more or less 2% of the entire emission. So we are aware that the products we build and how they operate during their life cycle determines how green our networks are. And then a tricky question, one more, the last. Does green development means ICT powered by the green energy? Because of course it does, we cannot say it not, but on the other side, we need to think a lot bigger than this. Because green energy, as we can see, it's a process. We are getting there, we are becoming more green as an economy itself, but it will take still a lot of time. In the next 8 years, still less than 50% of the energy sources will be the renewables. And if we look at, for example, the base stations, currently less than 1% of base stations are green powered or semi-powered. So this is a still long journey. This is something that we definitely have to focus on, but we need to act here and now, and we need to make sure that the equipment and the technology and the networks we use are as green as possible. So how to think bigger and how to make sure that we deliver the networks which are more sustainable is something which we call a three-layer indicator-based approach. This is how we work with our customers to help them reinvent, rebuild their networks to become more sustainable. It's based on the 3 layers, starting from the sites, the green base station sites or the data centers, through the green operations, all optical networks, and the green operations using the technology to optimize the operations of the network. Of course, every approach needs to be quantified. Any effort that we make to make our networks more sustainable needs to be measured in a way. And unfortunately, until now, we don't have any kind of unified indicator system to measure how much carbon we generate. And this is what we actually worked on together with our customers. And we developed something which we call the network carbon intensity indicator. Well, it's pretty complicated. It goes pretty deep. But basically, it helps us to measure how much carbon emission we produce for every piece of data we transmit. And that way, it helps us to analyze which areas of our networks are more sustainable and which area needs the more critical approach. So let's have a look now on these 3 main layers and see some examples of how we currently work with our customers to upgrade and kind of enhance their capabilities in the green approach. First, the green side. How we understand the green side is simplified, renewable, and intelligent. And it's, of course, easier to see on the examples. So here's one of my favorite projects we did last year. Well, we started last year. We're going to continue in the next 2 years with Deutsche Telekom in Poland. So what you can see on the left side is the typical base station site how typical base station site looks in Poland. So what we did is we managed to move all the equipment from the indoor shelter to the outdoor cabinet. It's a lot smaller, it takes less space, less footprint. It also doesn't need the air conditioning. It uses the natural air cooling from the outside. So, well, that way we save a lot of energy. On the other side, we use the solar panels. You can see we put the solar panels in this funny way vertically on the pole to source as much solar energy as possible. We use inside the cabinet, we use the lithium batteries, the new technology batteries, to store the energy generated so that we can reuse it, for example, at night, because basically we can manage during the day whether we want to source from the traditional sources or we want to source from the solar energy generated. If it comes to the outcomes, well, basically the results are pretty impressive. Since last year, we managed to save the electricity bills of over $22,000 in this 140 sites deployed so far. But more importantly, we saved over 100 tons of CO2. This is the first phase, and we plan another 2 phases so that in next year, we'll reach 1,000 green sites. But the green side itself is not only about the solar energy, as we said, yes? It's a lot about the technology we use. What you can see here on the left side is the typical base station, where over time, with the new generations of telecommunications, we were adding the additional antennas. This is more or less how the typical site looks. What we did in Switzerland, together with Sunrise, we managed to replace those legacy typical sites with all-in-one solution, the Blade AAU Pro, which consists all the telecom generations in once. So basically, what happened is we managed to move the 5G and the 4G generations, which usually take the lower levels of the base station, because this is where usually we have space, all the way up the pole. Bringing those generations higher, we managed to increase the coverage. So basically, as the result, in Switzerland, we managed to decrease number of sites by 20%. So that's another example. And then if we talk about the technology itself, another super cool example is the Meta AAU. That's the newest baby, I would say, we have. And this example of antenna where, in 5G era, the antenna works based on the beamforming technology. So they generate beams to address the particular users. And basically, in each antenna, normally you have 192 dipoles, the antenna units. What we did in this case, we managed to double the number of antenna units. When you have a higher number of antenna units, you have it more dense. That means the beams you generate to target the customers are more narrow. If the beam is more narrow, that means you use less energy to target your customer. That way, by doubling the number of antenna units, we managed to decrease the energy needed without losing the experience by 30%. So that was if it comes to the sites. And now let's have a look at the network part. We call it an all-optical transport approach. What we did with Telefonica in Spain is we managed to, for the first time ever, use those solutions we call the optical cross-connect cabinets. So basically, instead of 12 racks they had in each location, we managed to replace them with only 1 rack. We saved 90% of space, but more importantly, we reduced the energy consumption by 40%. So if you think of the scale, I mean, I will not even read the huge number down there, but that's a huge amount of energy we manage to save yearly. But all optical goes well beyond this. We think even our houses, even until the very last point, we should be using the green technology as much as possible. So this is why we introduced something which is called the fiber to the room solution for the customers who live in the bigger villas and usually need more than one access point, more than one router in their house, to connect those additional routers through the fiber connectivity, the green connectivity. So basically, something which normally will be connected through the network cabling or wireless through Wi-Fi mesh solution can be now connected through fiber. This is an invisible fiber, we call. You can basically stick it by yourself. It takes up to 2 hours to connect the entire house, and once you stick it on the wall, it's invisible. So that's basically the fastest and the most efficient way to make your house more green. The operations itself, Superstar platform is an intelligent platform which uses the AI algorithm to analyze the current traffic of the network. So for example, at night or in the moments where traffic is lower, we can switch off automatically some of the frequencies, for example, so that if we don't need the energy, when we have the lower traffic, we can basically, by default, the platform can reduce the operations of the particular base station, for example. In that case, for Orange, we managed to reduce the energy consumption by 30%. And the last, but definitely not the least, the data centers, the factories of 21st century, which don't produce the smoke, but they produce huge number of data, and they consume huge amount of electricity. So we build data centers together with our customers, starting from the very early stage of planning the data center. We have those algorithms which help to analyze which location is the best place to build a data center. So we analyze how far we are from the end customers, how much sunny the location is, because the more sunny it is, the more energy you use to cool down the data center. Or for example, if you can build a data center somewhere nearby the water base, because in our data centers, we very often use the liquid cooling, the water cooling, instead of the air cooling. Water is a lot more efficient. It helps to a lot more precisely chill down the servers, so that basically you use a lot less energy to chill down the entire space, because you don't chill the space, you chill the particular servers. On the other side, the data centers are prefabricated. They are made of modules, which are fabricated in a factory, moved to the right locations, and built on there. That way we reduce the carbon emission during the production stage by 50%. All right, so that's more or less some of the examples how we help to make the ICT a lot more green. Just to quickly summarize, green means simple, but also renewable and intelligent as well. By simple, we of course mean less devices, less network elements, making the network itself more simple, more easy to operate, and less energy consuming. We have and we bear this huge opportunity and potential to enable the carbon emission globally. So this is why we all should focus so much on helping ICT industry to enable their potential and to help globally reduce the carbon emission. And of course, we cannot just focus on the green energy itself, but on the complex solutions, think in a complex matter end-to-end, how to make our networks more green so that we can generate more bits and generate at the same time consume less watts. Thank you very much. That's all from my side. If you have any questions, I'll be super happy to answer.
Even the hole becomes green, you see? Green light is here.
Now I see. I think now I'm super relaxed and now I see.
So any question? Probably.
There was a lot of numbers, a lot of data, so if you have any questions, I'll be here and I'll be happy to answer.
Okay, thank you, Hieronym.
Thank you very much.
Yeah. The last presentation for this session is some system solution for testing quality of service in fixed and mobile networks from EVS Instruments. The presenter is Ms. Sanja Markovic.
Yeah, good afternoon. And first, I would like to say thank you to the agency for good organization and for hospitality and for the opportunity to present what we do. Okay. First, a few sentences about our company, if somebody maybe doesn't know us yet. So, company is founded in 1996 as HP distributor. Now it's called Hewlett-Packard. Now it's called Keysight Technologies. Yep. And during the years of work, we have partnered with a lot of leading vendors in ICT sector. So you can see the current overview on this slide with all the vendors that we collaborate. And having all these vendors in one place, this provides us some possibility to cover and provide solutions for both fixed and mobile quality of service. We have a headquarters in Belgrade and 3 other offices. One is in Macedonia, the second one is in Bosnia and Herzegovina, and the third one is, and the newest one is in Slovenia. Okay, so regarding wireless solutions, we will discuss 5G challenges and tools that help in this area. And the portfolio that in this domain Keysight provides is layered. It offers collection, control, and post-processing. So collection is where you collect the data from the field, data from user equipment, and over-the-air data is also collected in this part. And you can also control all these devices on the field, which is control and monitoring part. And at the end, there is processing layer, where you would actually take the data and perform analytics under this data. Our customers here are spread over the whole ecosystem, so it includes mobile operators, network equipment manufacturers, regulators, chipset vendors, and service contractors. And Keysight is investing a lot in 5G, starting in the development stages of this market. Because most of the cellular data today is consumed indoors, performing 5G indoor benchmarking is vital. People increasingly using phones in shopping malls, theaters, sports arenas, and demand uninterrupted high-quality access to wireless networks. And however, in-building tests can be complicated. Benchmarking equipment is typically very bulky and heavy. And what is more important, the equipment may only support limited number of test devices, which leads to added costs since you can't test all network and services in one go. And also the significant increase in path loss caused by 5G poses challenges to test equipment. The structure and design of the equipment may greatly affect, even to make some problems with test results. And Keysight at the moment has completely redesigned its advanced portable benchmarking solution to help our clients to make indoor benchmarking tests reliably and cost-effectively. The new Nemo Backpack Pro hosts a lightweight carbon fiber structure with easy access to the test device, and you can connect as many as 18 devices in Nemo Backpack, which means you can benchmark three operators and with 6 devices, which is used for drive test or walk tests. This can, in this way, you can save up to 50% of benchmarking costs, as there is no need to go to the same location twice. The high-end design of Nemo Backpack Pro ensures that there is no attenuation caused by equipment and that the test devices are radiation-free conditions because they're all, as you can see on the picture, all on front panel, so there is no any interruptions that are made by them. Even though this Nemo backpack is designed mainly for walk testing, it can also be installed in car using ISOFIX mounting. And the test vehicle cigarette lighter connector can provide sufficient power for the backpack. And this redesigned backpack makes in-building benchmarking of 5G networks reliable and cost-efficient. So as broad-scale 5G development continue in the world, the mobile operators and regulators are ramping up benchmarking activities to understand how their network performance is done and to see how they are standing according to their competitors and to verify the experience and service quality of their own 5G network. However, some benchmarking equipment support only a limited number of test devices, which leads to added cost, as we mentioned, to do tests in a few rounds. And also there might be issues with reliability and robustness of the toolset. So Keysight has in this manner launched a fully scaled drive test solution to enable mobile operators and also regulators to test wireless networks reliably and cost effectively. And extreme robustness, mobility, and reliability have been the main drivers in this new design. This solution is called Nemo Network Benchmarking Solution, NBM, and it offers first-to-market support for the latest flagship devices and technologies. And with NBM, you can reliably capture a complete set of measurements in single drive test for large-scale campaigns, so it can support up to 48 measurement devices. The extremely modular design of Nemo Network Benchmarking Solution enters the future-proof upgrade path for your benchmarking investments, so you can easily upgrade it and expand it in the future. Thanks to the distributed computing, the whole solution, the whole system runs on a single computer, and all tests are run by Nemo Active testing application on the test devices, and they are reflecting a real end user experience on the field. Combining Nemo Network Benchmarking Solution with Nemo Cloud and Nemo Analyze, it gives the whole end-to-end solution for data processing environment. And from the collection of measurement data, analytics and reporting, Nemo Network Benchmarking Solution delivers comprehensive and reliable measurement capability, enabling you to collect measurement data and capture all relevant key performance indicators for effective identification and the quality of experience and quality of service issues. And so this is regarding these solutions. When we speak about quality of service of fixed networks, we have a collaboration with Austrian company which is called Aladdin IT. This is a company which developed net test solution which monitors quality of service and quality of experience of internet access and services based on BEREC recommendations. The solution is developed in collaboration with Austrian regulatory agency. The objective of the measurement tool is to provide the reference system for monitoring of the quality of service aspects such as speed, delay, as well as aspects of traffic management, such as the blocking and throttling of internet-based applications. And today, NetTest covers user experience and on end customer devices, performance via hardware boxes which are put on the end customer site if there are any complaints to monitor the situation on site, and it also includes real-time monitoring of networks. Also on the right side you can see a broad network field quality of service testers, so handheld devices which covers testing in Ethernet, XDSL and HFC networks. And the last solution that we want to present is IPI in collaboration with Ookla. IBIS Performance Insights, IPI, is a software platform developed by IBIS Solutions. IBIS Solutions is part of IBIS Group. This is a new company which came from IBIS Instruments and which is dedicated to software development and software solutions in also ICT domain. So this is a platform developed by IBIS Solutions, as we said, which provides a unique way to monitor various types of network elements in any communication network. So whether it is a cable, Wi-Fi, mobile or MPLS. From head-end system down to the customer CPE, including measurement probes installed on customer premises, and as well as integrated crowd data analytics which are mapped to customer locations. So IPI can therefore successfully address both options, individual or as well as massive number of complaints in a reactive or even a proactive manner. By using IPI, it is possible to quickly identify grouped complaints and correlate them easily with network operators' bottlenecks. So when the problem comes out, you are trying to find the root cause of the problem, not solve some end problems which are related to some center from which the problems are coming down. And also, when we mentioned the Ookla, everybody knows that this is a big database of, it has a big database of measurement results, and IBIS Solutions, for that reason, has made a collaboration with Ookla, which enables correlation of IPI measurements and Ookla crowd data in order to compare KPIs provided from those two systems, and which gives unique methodology for end-user quality of experience in fixed and mobile telecommunication networks. This is done by mapping geolocation provided from IPI and Ookla samples, and metric correlation between these two systems can result with anomaly score. And this way you can get a picture in which way next steps of improving your network should be done, and also enables proactive optimization of your network. So this is it from my side.
Thank you, Sanya. Oh, everything. Yeah, questions? No questions. Nice. We are too fast this morning. I don't know why. Maybe from the last night, or maybe for the continuing of the last night that is following right now. Okay, first of all, I would like to thank to all presenters for this session, for their presentations. Also, I would like to thank to the presenters from the yesterday. We finish our conference with the working part of the conference. I'm very thankful to all of you as a participants and as a presenters also, that we shared our information between us, and also that you came here after the Corona time, after 2 years. And I hope that the next conference, our next conference, next year will be much better than this one. Thank you very much again. I would like to share another information with you. Actually, we have another session outside after this. In 12:30, the boat will be wait for us on the beach here, and we are following with the boat to Svetinau, to St. Neum. There will be some party, I don't know what will be there. You are welcome to come there to see what will be there, everybody. Thank you very much. I don't know if somebody else wants to add something.